Good day, my friends. I want to discuss with you the basics of aerodynamics, and I've made a few notes here with pictures, and I'm going to show you on this model that you've seen how inaccurate is this model for perfect flying, and we're going to do this and correct this one according to what I say here, but just with a hand launch. So lift, why does an aircraft fly? This is now for the guys that don't know. I know a lot of you will know this principles, but nevertheless, on an aircraft wing, you will always see it have that type of shape, and precisely 1/3 from the leading edge, 1/3 is the highest point of your profile on a wing, and 70% of the lift of an aircraft comes from the top of the wing, and only 30% from the bottom. But what that explain is the leading edge. If this is the 0-degree line here, 0, if you draw on the aircraft, if it's in flying position, from the leading edge to the trailing edge, that artificial line must be 4 degrees for optimum lift, so that you have your 70% lift on top, and that is a vacuum, guys. It's minus pressure on top, because the air that come from the front rush through there over the wing and accelerate. That is exactly what Bernoulli's theory is on a Venturi. So the air rush over the wing, and it slowed down on the bottom, and it gives you that 30% cushion effect, positive pressure from the bottom, and it suck on top, but give you 70%. Okay, so this is, and if you look at this aircraft, there is a negative pressure, a negative angle in, and not at least a 4. So we're gonna correct that. And then you've got from the top, you've got laminar airflow over the wing. It's very important that it must be very smooth on top. And if you look at this wing, you can see the imperfections. Say, for instance, if you've got a light, see you there, that's casting marks. All over this wing sit of that marks, and that I must take that away so that it smoothens the laminar airflow. This will break the airflow and it will not fly correct. So I need to take all that away and give it a positive 4-degree angle. Okay, then if you look at this picture, okay, what I have tried to explain here is the wing tips. You can see the tips is somewhat bent up. So what actually happened in the aircraft, when this positive pressure on a normal wing, normal old type of wing, the pressure on the top, on the edge here of the wing, try to break away to the negative area. It's obvious because it's positive, negative, and the positive air want to break away over the top, and it creates turbulent air on top of the wings here, which give you a tip stall. And that's why aircraft, mainly lately, you will see this round shape, or others have a flat wing with a little wing that sit on straight up. Wing lids, I think they call it. that prevent this air to slip over from the bottom to the top and create turbulence, so that now it go straight off. So this help a lot for tip stall problems on aircraft. That is why that is there. Okay, then if we go further, the center of gravity, you can see there, the center of gravity of the aircraft must be exactly, again, 1/3 from the front. So it depends on what engine. If your engine sit in the front, your wing will be much more situated to the front, because your weight is there, and the swivel point of the aircraft must be on your third of your wing. On aircraft where the engines is at the back, you will find that the wing sit more to the rear to counteract for the center of gravity. So we will check this on aircraft as well. And then there's three forces on an aircraft. It's thrust. That is your force that push your aircraft forward. Normally, obviously, an engine, or by its own weight, like in a glider. And then you've got your drag. That is all the wind force from the front. That is the drag, and you sit with a component of gravity that you must overcome. So that is your three main factors to fly perfect, is you must overcome gravity and keep on thrusting forward to keep your speed, and to overcome the drag as well. Okay, so this is what here's the picture of like the latest aircraft. They have this winglets. That is exactly to prevent, so that air from the bottom come over and become turbulent here, and you get a stall. Okay, guys, so this is just a basic, very basic description of aerodynamics. And if I can show you on this model, can you see there's the wing? This part must be underneath the body. So I need to move the wing this much to the one side in order to fly more or less straight. And that is all because of wings that is not in the correct angles. And also you can see here, you can see the extra drag because the casting is not good. There's a typical high point there. I must take that off. And you can see the leading edge. Look how bad does the leading edge look. It must be perfectly round, as well as I've seen somewhere a good example of a bad, here on the rudder. You can see there, this will tend to push the aircraft in that direction. This must be all go off, and I must shape this. You can see it's just flat. I need to shape this correctly, do something here on this fat side there. So I'm going to do this so that you can see what I do. I want to take the wing off and show you the imperfection on the casting. If you can see the one half there, there's about 1 millimeter, and from the other side it sits on there. So this push the whole wing totally skew. So we're going to correct everything. Look on top as well. You can see. So this whole aircraft needs a makeover. You can see there it's totally misformed. So I'll correct everything, make this nice and sleek at the back, because here you will have drag. The air that come off here will break away and break the aircraft, because the wind will not go smooth off. It will definitely have an influence. So we're going to make this aircraft to fly the best it can do. Look at this imperfections. This is also not good. So guys, on the next video we're going to tackle this aircraft and make a one video, correct it totally and give it a test fly. Okay my friends, see you in the next one and hope you would like it. Bye bye.